Hello, everyone. Welcome to my presentation today. And we are going to be learning about an exciting new framework technology that's connected with the hot large language models everyone is talking about today. So, welcome to the presentation. Hope you'll learn something useful today. And just a note, what we're going to be talking about today is really cutting edge. So things are changing daily. Some of the concepts you're going to hear about today are being defined right now, but it all makes it even more exciting. When it comes to agenda, just to give you a quick view of what we're going to talk about today, we're going to learn basic concepts about LangChain and what it is. And then I'm going to pretty quickly go to practical examples, which is going to be a mix of my code and the code from examples. And then we're going to conclude with what you can do next and how you can better use this technology. So I'm going to start with LangChain itself at first. As you can see probably, and you're probably one of the users of ChatGPT, everyone is talking about large language models, and people are starting to think, what are the applications of those large language models, since they're so good now, beyond just chatting? And if you've been thinking about what you can create with those large language models, then you probably can see that many people are building basically just basic UIs for OpenAI API using ChatGPT. And well, this isn't interesting. Large language models are what I call a powerful translation layer between our language and what is happening on our machines. And the understanding of concepts that is encoded in those large networks, or a basic reasoning skills that we observe in those language models, are a really powerful way, a powerful thing we can utilize in a variety of applications. And I'm going to show you in this presentation how to take large language models from something being a toy or being a novelty to something you can really use in your applications on whichever level of programming you are. I think this talk will let you imagine different applications or prototype stuff that is going to be exciting for you and for potential users of what you're going to do. So when it comes to LangChain, if you haven't heard about it before, it is a new buzzword. It's a library, a framework. And just to show you a scale of popularity, when I was checking out YouTube videos about LangChain like 2 weeks ago, there were like 10, and right now it's 50. And it's going to only ramp up as the company got investment. And it's being mentioned here and there in technology podcasts and everywhere around. So LangChain in principle is a framework for building AI-driven applications. It wraps certain techniques with useful APIs, provides tools and modular components that will allow you to build prompts and access data and structure data, and also go beyond just talking with language models. So you'll be able to reach internet resources, you'll be able to talk with databases, you'll be able to execute multiple steps with LLMs without interacting with you or a user. So basically, it simplifies what is now being called prompt engineering. And as you'll see, manually constructing prompts is not where we're going. And some data source connections and tools interactions are made much, much easier with this framework/library. One important note, LangChain has Python and JavaScript APIs, and they are not the same, but there are many overlaps. And most of the stuff you design in Python then can be taken to JavaScript to productionize the solution, but also it goes both ways. If you prefer Python and you're on this presentation, you'll learn concepts that you can pretty much transfer right away to Python. So I think this is really crucial that this decision was made for this library, because we can work more on the data and exploration side with notebooks in Python, and then bring those some of this code to production by simply translating it to JavaScript APIs. When it comes to use cases of LangChain, just to give you a general idea before we really start looking at the code, is there are many exciting things you can do. So some of the stuff is creating autonomous agents. You can tell LLMs to design a process of completing a task, and then the process will be executed by the same LLM using tools you give, and this LLM will use the tools you give it. So, and just to mention, I've been saying LLMs. LLMs mean large language models. You can use LLMs to clean up data. Imagine you have unstructured text or descriptions, and you want to extract JSON objects containing well-categorized data. So one case could be your users who specify an industry they're working in, but you only have 20 or 30 categories you want those industries to fit in. And so you can take those industries and ask LLM, using its understanding of language, to match what your users gave you to those particular categories. And you can extract it from walls of texts, from descriptions, not only from anything that has structure. You can use LangChain for summarization, pretty complex summarization of various data sources, and you can use it to interact with APIs. And I think when I show you practical examples, you'll have a better idea of what you can actually do. So when I'm looking at all of this, and you may see that in those code examples, that LLM is such a versatile tool that you can use it for replacing a lot of solutions that you were forced to write or prototype with lots and lots of code. And I saw those discussions: will AI replace software developers and by writing the code for us? And the answer there was no, because you need to guide an LLM through the app creation. You can ask it to guide itself, sure, but still there is a big gap before you can actually take this code and bring it to production. But this way of using LLMs I'm going to show you so is vastly different, because there is no code to be written for execution. Some of the tasks I'm going to show you, you're giving enough agency to the model that it can execute stuff for you, and then you can error correct it if it's not right. It may sound scary to you in a way. How do you test it? How do you get expected results? We already have some solutions for it, and I'm going to show them to you. So let's go through the features. I'm going to start with a really basic ones, and you'll see LangChain as a library that makes working with language models easier. But then we're going to go through much interesting use cases. So let's look at some code. I have my ridiculous big pointer here. As for installation, it's just one library. And since last week, it's also browser compatible. So if you're not using certain features, you can use it straight in the browser. Also, one important thing, the API changes. This library really became active this year. So some of the imports may change, but this is the state as of this week, really, because I've been going and running all those code examples today. So I want this to be practical, so I'm showing the full setup. You need to install LangChain, and also what you need to do is to set up an OpenAPI key. So what you need to do is to go to OpenAPI and register for API access and generate your API key. Also, what you will need is an API, for one example, for Google Search API via SERP API. It provides a free tier as well. So you're good to go if you want to execute those code examples. Two caveats. If you want to see the code of all those examples in GitHub, I'm going to put it there. It's not ready yet. Around tomorrow. So you can see links where to follow me in the footer, or I will probably add them to the comments of the recordings that will be shared after the presentation. So I'm talking about language models in general, but as you can see, we're coming back to OpenAI in here. So what we're going to do is, as our language model of choice, for now, we're going to use GPT 3.5, so the one running ChatGPT, because A, it's great, B, it's very simple, but what you will learn is that LangChain supports communicating with other large language models, so hosted by other companies, but also you'll be able to self-host language models on your own, like those Llama and other fine-tuned models that were released recently. And also there is, I think, now one language model that is available open source and for commercial use, which is great. So I'm going to be using GPT 3.5, which is great and cheap at the moment, but you can go beyond that. And some of the features will be really useful for models with a smaller context size. So what you can see in this code example, really, we're setting up OpenAI accessor object. We are specifying a model name, and then we set temperature. If you're not aware what temperature for those models is, it's you can probably call it creativity. So it goes from 0 to 1. And if you want a really strict answer, low hallucination. So if you don't know, hallucination is when language models really make up facts. You set it to 0, but if you want really creative answers, maybe a little bit out there, you go with 1. So in this example, we're just calling a model. What is the best way to learn new concepts as an engineer? And we get a response. So in principle, you can see that basic feature of LangChain is just wrapping OpenAI models or just other models and accessing them in a uniform way. So even if you want to just use a model in your app, then you have a common API that you can then use to switch different models and test different models. But then we go to prompt templates, and prompt templates will make you ask questions. Why do I need this? But you'll see that in a second. So we have some imports. I'm keeping those imports here for a few slides so you actually see what the practical code looks like. Then we also set up a model with the same settings, and we imagine you have an app, and this app is able to generate company names. It can be, a module of your application, of your hosting service, whatever. Like, you can generate different names for different stuff. So in this example, we're going to create a prompt template, allowing us to generate a good name for a company that makes certain products. And this prompt is really simple. But if you had an app that allows you to just insert product names and generate company names, you can use this prompt template to provide examples of what are good product names, or in this prompt, in this template, encode knowledge about product names that you want the model to use. So that's like one of the simplest usages of LangChain, you create a new prompt template object, you pass to it template and what variables it should use, and then you create a new LangChain. So the titular chain of the LangChain library. A chain means just a chain of language models and tools. So you create a new LLM chain and you pass it the model and the prompt template. And then you can just call your chain passing a product, an object with a product like socks, and you get answers. So you already see that this is one layer over a language models that makes using those a little bit more reproducible. But that's just the first step. So as you could imagine that you'll have a small app or part in your app that will allow you to generate certain names. I actually generated the API for it and generated the UI with ChatGPT. I asked it to make a small UI for this presentation. But that's still very basic. You can still just go, the prompt is small, you can just go to ChatGPT and ask it. But then there are other concepts in the LangChain that we can use. I'm going to show you quickly a concept of memory, but what was really impressive about ChatGPT was that it remembers what you've been talking with it about. And how it does it, it basically takes your previous messages and passes them with each next message as a context of what was being said. So it is pasted before. And you can see that example in here. So when we look just at the line 3 and just at the template, that's basically a system message of ChatGPT. The following is a friendly conversation between a human and AI, and the AI should be talkative, provide details, and if it doesn't know, it will tell the user that it doesn't know. And this, when you're using ChatGPT or the API, Chat Completion API, that's what is there by default pretty much. And then how it works, it basically pastes chat history somewhere in there, pastes your input and puts a place for an AI answer. And while this is available for ChatGPT, it's important to know how it works. So ChatGPT has also a finite context. But what we're going to be doing is we're going to be using one type of memory. So it's buffer window memory. So it's a kind of short-term memory you can use for your model. So in this case, we're going to use buffer window memory. And as you can see in the name, there is window. So we're going to buffer just one previous message. Imagine you have a very small model that has a context of, say, 500 tokens. And just for people that don't follow that, a token is a number you encode a piece of text with. So you can imagine that when you provided a sentence or text, each word can be a token. In reality, token is usually a combination of a few letters. So before your text goes to an AI model, it gets through a tokenizer, and this tokenizer encodes your text as a string of tokens that only then go to the AI model. So because of the token limit, like 500 tokens, you won't be able to pass a long history. So you may limit it to one last message. And that's what we do here. We use our conversation template, and then this can be right away used to create ChatGPT copy with some open source models. And we start a new LLM chain where we pass our model and our prompt and our memory this way. And we tell the model that, hey, I'm Jim. What we'll see is a response that, hi, Jim, I'm an AI based on this template. And then when we ask it what's my name, it will say that my name is Jim and that it can help me more with other stuff. We have a parameter how much messages to remember in the memory. I wanted to show you the context of memory because that's an engineering layer over large language models that OpenAI used, and that's what really one of the pieces that made people excited with those models. Important thing is this is only short-term memory. You can use other ways of remembering. Another type of memory you can use in LangChain, and please explore, there are tens of them. You can use summarizer memory. So after each prompt, you use another model instance to summarize the conversation history. So in this way, as a memory, with every other request, what will be passed is a summary of previous conversation, not all of the messages. This way you can really save on context. And this is a recommended thing for working with smaller models, or even with large models that you expect to have a long conversation history with. And this makes sense, right? When you have a conversation with someone, you surely remember only the most important facts. You don't hold the whole conversation in your brain. So that can be really useful. But I just wanted to show you that memory is one of the features of the library, but it's still for conversations or for going through the large investigation process with an LLM. But we're still operating in a realm of concepts that are known for us from chat applications like ChatGPT, or is pretty imaginable. I want to talk about something that is really interesting to me. I showed you a structured input, so you can pass pretty much a JSON object and use it to construct a good prompt and get an output. But the real power of LangChain is allowing you to get structured output reliably from large language models. Imagine you're analyzing a huge corpora of text, and you want structured data out of it. You're going through a research paper, and you want to extract from it certain ontologies, certain names of diseases, drugs, whatever. You want to go through a job description and extract all the technologies that were being mentioned and skills that were being mentioned in order to understand what a company does and what's their tech stack. One of the early apps I saw using LangChain does exactly that. It crawls through job descriptions and maintains a database of companies and their tech stacks based on those job descriptions, and then sells this data to people interested with lead generation and other companies. So how do we get structured output out of LLMs, which basically spit out language? We're going to start with defining a schema. So there is a library in JS that's used for validation, also in TypeScript, and it's called Zod. So here I created a simple output. We're going to create a fake identity generator. We already have like Faker.js and libraries for generating those, but I want to show you just a generation example. If you give an LLM an input of text that you want to extract certain information from, it will do that as well. What I'm looking at here is I want to create a schema using a Zod library, and I'm going to expect as an output from my chain an object that has a name that is a string, and the description is really important because it will tell model what do we expect to get. I'm expecting a surname. I'm also expecting an age that is a number. I'm expecting a very short description of a human. And as you can see, I even made a typo in here, and it doesn't matter. I actually ran this code. We're going to generate a gender and also an array of interests. So that's it. And I didn't have to specify even types in here. It could be just human interests. I was experimenting with the library. So that's our setup. We define the schema we expect to get from our language model. Then, as you can see, we're going to construct a prompt. So a lot of the work here that is not fully abstracted away is still constructing prompts, because what we're interacting with is a language model, and it takes language as an input. I expect in the future versions of the library, you won't touch a prompt at all in most of the cases. So what we're getting is format instructions from our parser, because parser, apart from schema definition, has some functions I'm going to show you in a second. And then we're creating another prompt template. So we want a template that will ask LLM to generate details of a hypothetical person. We're going to add format instructions, and then we're going to allow our users to add what kind of person details they want to generate. So what we're going to do is just start this prompt template. And as you can see, we're expecting partial variables being they're included in the format as an output. So if we want to execute it, we just create another model instance. In this way, in this case, I'm going to keep the model halfway creative, just not to create something ridiculous. And I just want to generate a fake data of a man that lives in Poland. I don't care, because I want to generate hundreds of them potentially. So I'm calling a model with the input we just created using our parser. And then that's what's going to the model, actually. So LangChain generated a prompt for us. We want to generate details of the hypothetical person. We are expecting a code snippet with JSON data formatted using the generated schema here. And we want this generated schema to adhere to the description we've created. And that's what we get. We actually pretty reliably, as far as I tested, get JSON output with the data we wanted. So we get name, surname, age, short bio, gender, and interests in a JSON array. So that's an idea of data generation. But as I mentioned, a much more interesting use case is data extraction, which I encourage you to try to do. What we can then do, you may be, if you're an engineer and you've created a production system, then you may expect that, hey, okay, this is pretty error prone, because I don't know if I'm getting this output all the time, and what happens if it goes wrong. And that's another thing that the library gives you. When you run this code, when you actually await this model, and then you actually have to run another line of code, parser.parse, and you get this parsed output, you will get errors if the output doesn't adhere to the schema you've created. And additionally, if this error happens, you can use what's called a output fixing parser. So we're going to get the response we just got. I wrapped parser.parse, which is just using a parser we created at the beginning. So this parser, we're going to call it in the try-catch block. And if all goes well, then we're getting our answer like I showed on the previous slide. But on the case that there is an error and the output from the model is bad, we can use another model to correct the output that we got. So we're using output fixing parser, which gets another OpenAI model instance, and we're calling it with temperature 0, because we don't want it to come up with any data. We don't want creativity. We want just, if there's a fixed missing parentheses or something else, or the JSON format is not quite right, we want this output to be fixed. And this way we get auto error correction, but if it still fails, then we get exceptions. So we can then regenerate a response, or we can just try to fix the output again. So, we get error correction, which is really nice. As a next concept, I want to show you, I want to go beyond, because getting and working with data is all cool, but we can do more. So even the previous case was we were getting JSON input and JSON output, so treating LLM as a really versatile processing engine that will probably allow us to create apps that can do a lot, the basic reasoning, connect data points, and spit out output that we can use in other tools, which is great. But what we can do is we can use LLMs to as agents that perform actions. So let me go with you through this code, and we'll see what's going on. So I'm going to instantiate another OpenAI object with using GPT 3.5 model, and what LangChain provides is tools. So the two tools I'm going to use in this example is SERP API. SERP API is an API allowing you to get Google search results by API. And I'm also going to give it a calculator tool. And other examples of tools can be using an API, using Zapier automations, can be whatever you can really imagine. You can really create your own tools. So if you want to send SMS messages, execute SQL commands, most of those are already in LangChain, but you can create your own. So those tools usually contain descriptions of how to use them, and we expect our models to use those tools in order to execute actions. So we're going to create agent executor, give it our tools, give it our model, and now we're specifying a basic way of matching tools to actions. We call it zero-shot React description. I'm not going to go into details how that works, but you can print every prompt that is being executed and see how that works. And documentation also includes other prompt types. So what I ask this model to do is, using those tools, respond to my question. What is the difference in the number of countries between Africa and Europe? And what it did under the hood, it searches first in Google how many countries are in Africa, notes that down. It searches how many countries are there in Europe, notes that down, and then executes calculator tool to subtract the number of those countries. And it worked flawlessly. And you can ask it to do just that. And if you connect it to more exciting APIs or more exciting tools, you can ask it to execute actions on your behalf using those tools. So as you can see, you can wire up an application connecting multiple APIs based on requests without any code, any translation layers. So you can wire up really complex processing systems really without a hassle, using an LLM agent as a dispatcher of those actions. I'm going to show you another really cool example, how you can use agents. So let me quickly go through this example. In general, what we're going to do is we're going to load a Swagger / OpenAPI API specification, and then we're using LLM pretty much talk to this API. So ask LLM to execute actions in this API via language commands. So what you can do is load a YAML with an API specification. And when you do that, when you load YAML, then we just have to specify authentication. So in this case, we're going to be pretty meta and use OpenAPI spec. So what we want to do is create another model instance. Then we instantiate OpenAPI toolkit, which is a set of tools that will allow you to execute actions from OpenAPI specifications, from API Swagger specifications. So what we just do is we pass the specification of the API, we pass the model that's going to execute those actions, and we pass our authorization headers. Then we create another executor, which is going to be an agent that uses this model and uses the toolkit. So the reason why we're passing model twice is this OpenAPI toolkit uses a model to perform some actions to understand the API under the hood. And then this model is just our executor of this toolkit. So we're using the model with those settings multiple times. And then how it works. We're using OpenAI endpoint for chat, really. And we can just say to our agent executor, make a post request to /completions and send a prompt saying, tell me a joke. So this agent will know that based on the specification that the API you want to communicate with has an input called prompt. And then it will call this API for you and get an output. And what you can see in between is also what steps the agent took to execute those actions. When you look under the hood, you'll see that the agent asks itself, okay, what do I do to execute this command? And then it creates a string of commands that it needs to execute using those external tools and provides you an answer. Pretty cool stuff. As a last example, not to overwhelm you with different concepts in the LangChain, because I think it's been inspirational enough, I'm going to show you how you can do smart web crawling. So at the top, we're instantiating another OpenAI model. And one new concept is we're also going to be using OpenAI embeddings. Really short introduction. When you put some text into first step of many of the models is to convert text to what we call an embedding, which is basically a vector of numbers that puts a text in the context of other texts in the that AI saw before. So you can imagine that if I say anything to you, what I said is present somewhere in the text and language space and has distance to other things that were said before. So for example, I like cookies is much different than Maria went to school. They are living somewhere else in the vector space of language. But not going maybe too deep into that, embedding is a number representation of a text in this case that places it in the space, in the vector space, based on its meaning and other factors. So in principle, embedding is how the model will on the later stages see your text. So we're instantiating a tool called web browser from LangChain, and we're passing it the model and the embeddings we want the web browser to use to understand the text on the website. And what we're just saying is to our browser to go to a website that is an article about Joseph Campbell, and then we ask a question, who is Joseph Campbell? So we are able to query websites content for specific answers. And then we get a description of who Joseph Campbell is, and we get actual more relevant links from the website, more sources when this information came from. So you can do really smart web scraping without worrying at all what the structure of information on the website is, because what the model is going to do under the hood is we're going to ask browser to go to this website. Then it's going to convert the text in it to something the AI can understand, and then we're going to search in it for answer. What is happening under the hood of this web browser is multiple steps, but this is already coded for you in LangChain. So these were the examples I wanted to show you as a basics of what LangChain can really do. There are multiple other concepts in the library that can further drive your curiosity and your ideas for application development. I think you have more questions after this presentations that answer, but also some practical examples that you can use right away. What is interesting to get to read more after this presentation, it's vector stores. So I mentioned the idea of embeddings, but what you can do is get large knowledge bases and large pieces of data, store them in vector stores, and then use those as a long-term memory or a knowledge base. And this way, your language model or your application can have access to vast amounts of knowledge without retraining the model with new knowledge or something like that. We don't need to worry anymore about the fact that someone trained the model up to the end of 2021. We just assume that the model is just a language understanding agent, language understanding application, and that it can do some reasoning, but we don't expect it to know anything. We provide it knowledge, which is freeing. And potentially you may argue that after what we just saw with AI tools, there's no point to scrape internet anymore because it has so much AI generated content that probably to teach an AI what is going on in the world and how humans think, you shouldn't use knowledge after 2021. We'll see what kind of findings we'll see when we train models on the internet and unfiltered AI generated content. What you can also do is use other tools. And when you look at the LangChain documentation, there's a lot of them. So you can see SQL access, database access tools. You can pretty much talk to databases. And yeah, you cannot ensure how optimal those queries are, but you can actually talk with AI or do commands in language and get real structured results. You can also create your custom tools. If you have any tools you like to use, you can just wrap it around a simple object or even provided an open API spec, as I showed to you, and you can make LLM agent use it. LangChain also includes loads of utilities for loading documents. So you can load PDFs and do a text recognition right away, and then indexing and store them in vector stores. This is pretty much automated in this library. You can load straight from S3. If you're someone that builds your own knowledge base in something like Notion, you can load your whole Notion workspace into using LangChain, then load it into a vector store and use it as your use this AI having all of the stuff you encoded in your knowledge base in Notion. One interesting thing LangChain already has is Zapier integrations. So imagine thousands of tools in there that you can call with your LLM agents. The next thing you might be interested in, so OpenAI guarantees that when you use their API and you don't opt into data use, since March, your data is safe, but you can maybe use open source LLMs for more sensitive applications or if you want to save on cost. And also there are multiple chain types that you can use that just requires further reading. And there are many more features coming. Some of them are not documented. Don't be afraid to look at the source code and join in general the LangChain community, because what I'm seeing is rapid evolution and concepts are only now defined. So LangChain is now being production ready because the company that creates it or the guy that creates it got some investment and they're starting to provide paid support. So they had to make it robust enough. And we're already seeing applications with it. So this doesn't have to be only exploratory data analysis or just applications that are pretty much toys. You can start using it with the LLM of your choice using the safety restrictions you have. So to conclude what I said today is that I see and many other people see the vast potential of using LLMs in various applications. It is not an expert AI model trained to understand everything, but because it was trained on language, it can understand concepts really well, or appear to understand concepts really well, and help you extract information, perform actions, and in general automate a lot of stuff. LLMs paired with tools um, can do a lot, and we're only now still learning what they can do. As you already saw, we can use LLMs to self-correct themselves, fixing outputs. We can use them to query themselves in order to perform various actions. And this concept is really, really powerful. The landscape is continuously evolving, so the use cases are unexplored. What you can do with LangChain is really up to you. And I think there's a chance to be first in many of the areas. For example, I know that no one yet presented LangChain in JS in this form and in this overview. And I already see many applications that I can use it to. I also know a friend that already integrates LLM via LangChain into a huge reporting product. So exciting stuff. And what I would recommend is to take interest into LangChain, into large language models, see how you can use it in your projects, and contribute to the future. So as I mentioned, there's going to be the resources for this are going to be available on my socials, but also feel free to follow me on Twitter, LinkedIn, or on my website. I also have a article on how to generate PowerPoint presentations using ChatGPT, which I used to generate the template of this presentation, but then of course it required a lot of coding work. But yeah, now I'm open to your questions. So if there are any, please shoot them my way. And also the recording of this talk is going to be available on YouTube and Facebook. So you'll have access to it afterwards. Are there any questions? Okay, yeah. So we've got an answer on using LangChain for and GPT-4 for contact with someone's business, and how to ensure that that we know that the data is 100% secure. So for that, is you have to ensure certain things and manage your trust. So per OpenAI's API documentation and their privacy policy, since few weeks, they guarantee your data is not used for any training, and it's being removed right after passing it through the model and giving you an output. And I think we can take their word for it as much as another company. And since Microsoft owns 49%, we cannot treat them as Microsoft, but their guarantee is something you have to take their word for. And I don't see any other way around that. And with other tools like LangChain, it's an open source library, of course. The tools are being checked. So if you're interacting only with GPT-4 via an API, you have a strong privacy policy that helps you. And other tools, unless you post data via unsecure APIs, you should be good to go, and just treat this application as any other ones and make sure things are safe. Hope that helps a little bit. But privacy policy of OpenAI is now pretty clear on data usage. So when you send your partners links to those privacy policy, there is no point not to believe it. Thank you. Okay, we have a question. Would you recommend learning JavaScript or Python if I want to start building with LangChain? Ideally, I'd like to master LangChain in 5 months. So I would say this This, of course, depends where you're starting from. But as far as I know, if you want LangChain purely for data analysis, data exploration, I would go with Python, just because this seems to be a major language where the new features are born. But the feature parity is great, and Node has some features that Python doesn't. So it depends. If you want to focus on data analysis and using it for data wrangling and structuring data, then go with Python. But if you're more interested into creating production apps, and using cloud native approaches, using AWS Lambdas or integrating it straight with front ends, I would say Node. But that being said, you also can create Lambdas in Python. So depends on where you're starting with. If you feel more comfortable with JavaScript, go with JavaScript. The feature parity is really good. If you want to if you know more Python, I would stay with Python. No reason apart from doing front-end centered development for going with JavaScript, but also we'd like probably most of the stuff to happen server side. So I don't see big applications of that. So go with whatever you're stronger in, and yeah, you'll be good to go. Okay, we have another question. Can LangChain be used with local alpaca model to enter and search data? The answer is yes. I've already seen this application. And so what you need to remember is just about context limitations. There's already a wrapper object in LangChain for alpaca. There is actually even a YouTube video going through it. So yeah, you can use it. And if it's in Python, don't worry, you can just use it to install alpaca. And then the API is pretty similar between Python and JavaScript. So yes, it can be used with local model, and actually it's preferable. And many of the features like memory will make alpaca closer to what OpenAI provides with GPT. And you can jump across context length limitations by summarization of history or summarization of input text. So yeah, definitely look up summarization features of LangChain if you want to do that. Okay, we have another question. Are there LLMs that are available that you can use locally using data that has privacy requirements, and are they effective enough to be used by companies? So yeah, pretty much every other week a new open source model is released. I think the models based on Facebook's architecture are pretty capable, but I'm not talking about the smaller ones. I would go with the bigger ones, and they are being fine-tuned pretty much on instructions to open API models. So the larger ones are quite good. I've seen a model released last week that's ready for commercial use. I don't know the particular name, but you can use it even if you're selling it to clients, not for your use. So, but you have to remember the reason why I made this presentation using GPT 3.5 and I use GPT 4 as well is because it's the best. But LangChain will help you, as I mentioned, with summarization to breach a lot of the gaps. But even if like alpaca, llama, or other variations that were born based on those released architectures are not suiting your needs, it's a matter of short time, in my opinion, that those will be available. But if you want to really host a bigger model, then it's GPU cost, of course. So be ready to have a really good hardware on your side. No particular names from my side, but from the open source, there were a lot. I tested actually Vicuña, which is pretty good, but I don't know the name of the commercial ready ones. So if you send it, if you find it, then maybe comment somewhere so we can all use it. Yeah, so the question is, do you think that in the future it is possible to integrate AI with our IDEs? So we could just give commands to AI and it could modify and add files in the project. So yeah, that already is actually pretty close to being done. I saw a demo that you can go with AI to create those files, and there is nothing stopping you really. If you saw the presentation and if you really give a large language model an option to create files and then to access those and write to them, you already have it because LLMs are already good at generating code. So I think it is not only possible, but it's already being done. I saw a basic tool that does that. And also, as far as I saw, Copilot X can work across multiple files. I don't know if it can create files, but I'm sure they will add that. So already in LangChain, I think either is or is in development the file accessor tool, and if not, it's really easy to wrap file system commands from Node in it. So yeah, that's probably going to happen, and that's good because with current Copilot, you just pretty much had autocomplete on steroids, but now we'll have more tools. So far, I only saw a web tool. That's true. So integrating with IDEs would be great. I don't think Copilot X is actually, if you're referring to Copilot X, I don't think it has any. So the question is, does LangChain have anything to do with it? I think if it relates to Copilot X, the answer is no, because Microsoft and OpenAI probably don't want us to know their secret approaches, but I think it's pretty similar. And I saw a big podcast with pretty long podcast with Sam Altman, CEO of OpenAI, and what he says is the advancement with ChatGPT wasn't really in that much in AI, even though if it of course was, but compared to GPT-3, but in the engineering layer above it. And what I see LangChain being is an engineering layer above large language models. So I think this library just replicates a lot of the stuff that OpenAI does under the hood to make their product work. So I don't think Copilot X uses it at all, but the concepts should be similar. So the question is, can we assume that combining GPT 3.5 with the temperature set to 0 and SERP API drastically reduce hallucinations? Yes, that's what I noticed. And of course, there are ways that probably this can go wrong, which makes it being far from the production use. But in the limited testing I did, I never saw problems. And the temperature setting helps a lot with that. What you will see, if you want to test it just before interacting with the APIs, I'm actually using Bing Chat quite a lot, and it has 3 settings. You can set Bing Chat that uses GPT-4 to be conservative, pretty balanced, and creative. And when I use the conservative settings, I rarely ever get strong hallucinations. So it's the matter of testing and evaluation. I think we should I didn't see any large-scale tests of that, but I would say we're in a good place because SERP API provides a structured output, and it's a pretty dry SEO descriptions with keywords. So using that GPT 3.5 to summarize and to work with this data, I have a feeling that this could have a low hallucination level. Okay, we're at the point where there are no more questions. So thank you everyone for attending. I hope you enjoyed this presentation. As I mentioned, the recordings are going to be available. And if you want to continue this conversation, please engage with me on the mentioned social media links. Thanks a lot. Have a great day.